Okay, guys, we're going to do 4-1. Now, in class, we went over example 1 through 5. We took a little bit of notes, 4-1 notes on congruence. That's the topic of our chapter. And we're going to do these questions, 14 through 16 and 18 through 22. So let's do the practice problems. Now, if you're looking for these examples, you have to watch the team video or get the notes from another student. All right? All right. So let's take a look. It says, given the reflection, right? Capital R is reflect. Given the reflection of this triangle over to this triangle, so that would just mean this triangle flipped over, and now it's here. Do these two triangles have equal perimeters? Okay, so I would say yes, right? This is my short length, and it should match rigid motion. Means lengths and angles don't change. They stay the same. Right? So this length, the shortest side, and this length, the medium side, well, that might be a little longer. It's kind of hard to tell. This length, and then this third length, PR, matches PR prime. Those don't change. So, since QR is equal to Q prime R prime, and PR is equal to P prime R prime, and QP is equal to Q P prime P prime, then we should be able to add these up. Then I can say the perimeter of triangle PQR, which is equal to QR plus PR plus QP, should equal Q prime R prime, PR P prime R prime, Q prime P prime, which is also equal to the perimeter of this triangle. Cool? And we kind of know this just using common sense. It didn't change, so they should have equal perimeters. Okay, question number 15. Given this triangle, this quadrilateral, four-sided, looks like a rectangle, right? Given this rectangle is congruent to that rectangle, so maybe I can shade this. So this first rectangle, WXYZ, is congruent to this rectangle, keep saying triangle. Describe the composition of rigid motion that maps one on top of the other. So it looks like if we rotated it about W, 90 degrees, it would just land right on top. And there's multiple answers, so this is just one way. So a rotation of 90 degrees this way. Well, that's the same way a clock goes, right? So I'm going to say clockwise. So rotation in 90 degrees, clockwise. But that would take, we've got to be careful, right? That would take the yellow one on top, or the orange one on top of the yellow one. I want to do the reverse. So I want to make the yellow one lay on top, so I got to go counterclockwise. All right. So I'm going to go this direction, and that's counterclockwise. All right, 16. Are A, B, C, D, and E, F, G, H congruent? If so, describe how. Okay, so a couple of things we looked at. Pythagoras kind of helps us see this triangle here. It's a 1 by 1 triangle. And so that distance, BC, would just be 1 squared plus 1 squared, and then you'd take the square root. So let me just explain that. If you didn't know, so I'm going to call that C. If you didn't know the length of that hypotenuse, you'd do 1 squared as A, and again 1 squared as B, and it should equal c squared. So we learned that back in middle school, that a squared plus b squared is c squared, and it's very useful in this class. So 1 squared is still 1, 1 times 1. 1 squared is 1, 1 times 1. So that hypotenuse happens to be a decimal, which is not 2, it's actually the square root of 2. So if I get a calculator, the square root of 2 is about 1.4. So if I take the square root of both sides, I go 1.4. So C is actually 1.4. Now notice this is also a 1 by 1 triangle. So its hypotenuse would also be 1.4. So those have equal lengths. These are definitely equal lengths because they have this same triangle here. Okay, now let's just kind of work our way around here. This is a triangle that's 4 by 1, so it would have the same hypotenuse as this triangle that's 4 by 1. Okay, so we like that. We can match those up. So this one and this one are a match. Now let's look at this one, right? This is a 2 by 2 triangle, so its hypotenuse would match this hypotenuse, right? So this length and this length are equal. And last, we're going to look at this one. This one is a 3 by 2 triangle. So this is a 3 by 2 triangle. So that's looking pretty good, guys. I went all the way around. It's pretty much looks like it's a match here. So I'm going to say yes. A, B, C, D. Oh, it's not a triangle, though. It's a four-sided shape. Let me fix that. A four-sided shape, A, B, C, D, is equal to or congruent in measurement to this one. Yeah, that looks good. If so, describe the composition of rigid motion that would map it on top of that. Okay. So A has to line up with E. I have to somehow get A to line up with E. Does that make sense? So if I am trying to get A to get over here to E, I think I could spin it, right, at A, so that it would then match this orientation. So if I spun it at A, it would look something like that. So it looks like if I spun it at A, this line is now all the way over here at that line. That looks 180 degrees. So I'm going to say rotate. And again, remember that I could rotate it clockwise or counterclockwise. We normally like to do counterclockwise if so. So it looks like if I spin it or rotate 180 degrees counterclockwise, then it would be, I guess I'll use my highlighter. It essentially would be here, something like that, right? This would be my shape. And I'm trying to get it here, right? So now I have to move it over to E. Now A and E are still the same distance apart, but now they're in the same orientation. So I'm just going to count. How do I get from A to E? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's translate. I want to add 6, 3, 4, 5, 6, 6 to all the x values. And then I need to go up 8, so that's up 8. Nice work, guys. Check out the next video for the next page.